Professor Rakshitha from the Department of Civil Engineering. Today we will be looking into a topic in the module 5 that's super elevation in the elements of civil engineering. Okay, so we are looking into this topic called super elevation. Okay, to start with, let's just look into this picture. If you can see, the road is not exactly horizontal. You feel that the road is tilted or the vehicle is tilted since the road is tilted a little bit. And the next picture, if you come to the rails, you see this rail even this is tilted to some extent here. We don't see it as horizontal. But in both the cases, what is similar, if you see that, both the vehicles are taking up a curve. So when there is a curve, you can see such tilted condition, correct? Okay, so to be precise, let's check with this. When you're taking a curve, you feel that you're being thrown out due to this centrifugal force, what we have studied before. So to avoid that condition of feeling uneasy while traveling in the vehicle, uh, what we are going to do is, while constructing the road, we are going to give a slightly higher outer edge. So what you see, this triangle, this is the inner edge. When I'm taking a curve towards this side, I can call this as the inner edge and this as the outer edge. So the outer edge is raised with respect to the inner edge. Okay, so this is super elevated height, and the angle it projects, it's called as super elevation angle, angle of super elevation. Okay. So in detail, if we have to see, let's look upon this. A person in a moving vehicle in a curved path experiences an outward pull by a force called as centrifugal inertia force that we have all experienced. When we are taking a curve, we feel like we are thrown out of the road, out of the curve. So to avoid the undesirable conditions such as skidding and overturning, the outer edge of the highway curves or the outer rail on railway curves are raised above the inner edge or inner rail. So that's what we said. Like, so when you're taking a curve, you feel uncomfortable. So if you are in a high speed, there might be a chances that when you're taking a curve, if proper super elevation is not provided, there might be a chances of getting damaged. That is, might be a condition of skidding, overturning, whatever. So the super elevation is provided to avoid such conditions. So to be so precise, this raising of outer edge with respect to the inner edge is called as super elevation. So this is the definition, it's very important. This raising of outer edge with respect to the inner edge is called as super elevation. So super elevation is also called as banking in roads. So we saw two conditions where it is applied, like in roads and in railways. In roads, super elevation can be called as banking, and in railways it can be called as scant. So super elevation is provided based on the speed of the vehicle and the radius of curvature. So the super elevation depends upon the speed of the vehicle and the radius of the curvature that you are taking up. So what are these benefits of providing super elevation? Let's look upon that. First benefit, like we said, we can avoid feeling that discomfort while taking the curve. That is, we can avoid such effects like sliding, skidding, and overturning while taking up the curve. And second one, higher speed can be permitted on curved path. So if you provide super elevation, to some extent you can provide a higher speed comparatively. Lateral pressure may be reduced or eliminated, giving more comfort to the passengers. So the feeling of getting thrown out while taking up a curve, that can be reduced or eliminated. So the last one is wear and tear of the vehicles is reduced. Okay, so we are speaking of while taking a curve about centrifugal and centripetal force, right? So just to brush up what we have learned previously, centripetal force is the component of force acting on an object in curvilinear motion, which is directed towards the axis of rotation or center of curvature. So the term towards is very important in centripetal force. In centrifugal force is the apparent force which is equal in magnitude and opposite in direction to the centripetal force, drawing a rotating object away from the center of rotation caused by the inertia of the object. So when you listen to centripetal force, it is a force that is being pulled towards the axis of rotation or towards the center of the curve. And centrifugal is when you're feeling the object is going away from the center of the center of the rotation. So pictorially, if you want to see, centrifugal force is always away and centripetal force is always towards the center. And this force is always perpendicular to the tangent at this curve, and centrifugal force is exactly opposite to this centripetal force. So for equilibrium, if an equilibrium condition has to exist in such cases, then what should happen is centripetal force should be equal to centrifugal force. Only then equilibrium exists. So we know that for centripetal force, F is equal to, I can write it as mv square by r. And m, I can write it in terms of weight since we know that W is equal to m into g. Therefore, m is equal to W by g. If I substitute here, I'll get F is equal to WV square by gr. So let's look into some equations that are needed here. Conditions for skidding on level road. So this is the condition when the super elevation is not provided, when it is the road is at the level condition. So F is equal to mu into W. Let's see what's all this. F is the frictional force that exists, okay, and mu is the coefficient of friction between the surface and the vehicle or object on the road. And W is the weight of the body, weight of the vehicle that is being taken on the road. Okay, so F we already know from the previous part that F is equal to WV square by GR is equal to mu into W. So this comes from the friction part where we learn that coefficient of friction is nothing but frictional force divided by the reaction. So from there we are taking F is equal to mu into W. So instead of reaction, we are going to take the weight of the body, frictional force. So WV square by GR is equal to mu W we have now. So from here, if I have to need to calculate the vehicle speed, if I want to arrive at the vehicle speed on that road, the condition for skidding on level road, then V square is equal to W gets cancelled anyhow, mu into GR. So V is equal to root of mu into GR. So this is the condition for skidding on level road. That is V is equal to root of mu into GR, where mu is the coefficient of friction, G is acceleration due to gravity, and R is the radius of curvature. Okay, moving on to the next condition. Condition for overturning on the level road. We are just studying on the level road itself. First one case was for skidding and the second one is for overturning. So condition for overturning on the level road. So we just need to remember this is the object. If we take this as the centroid of this object G, okay, a centroid is nothing but where the complete mass of the object seems to be concentrated at a point. So here, if we consider this as the centroid, and the height of the centroid is h from the ground level, and this is the width of the object. V is the width of the object, or distance between the wheels of the object, I can say. So for such a condition, velocity v will be equal to root of g into r into b divided by 2h, where b is the distance between the inner and outer wheels, and h is the height of center of gravity g from the ground level. So this we need to remember. Like we have to remember for the skidding case in the level road, v is equal to mu into gr, v is equal to root of mu into gr. And here for overturning on the level road, we need to remember v is equal to root of grd divided by 2h. Then next condition is for skidding on banked road. Banked road in the sense where super elevation is provided. Since it's the condition of road, we are calling it as banked road. So for that, v is equal to square root of g into r into mu plus tan theta divided by 1 minus mu tan theta. So we know g here, r, mu is coefficient of friction. What about theta? We saw in the earlier picture that theta is the angle projected. We spoke about banked roads. So super elevation is provided. What is super elevation? We have the outer edge of the road is raised with respect to the inner edge. So in that process, there will be a projection of angle. So that angle is called as theta. Theta is the angle of super elevation. Okay, so skidding part is done. Next is overturning on the bank road. Condition for overturning on the bank road. That might be in the case of roads or in the case of rails. If you want to check, we have two equations to remember. While in the case of roads, v is equal to square root of g into r into b plus 2h tan theta divided by 2h minus b tan theta. And for rails, v is equal to root of gr into g plus 2he divided by g whole divided by 2h minus e. We know all the terms g, r, h, theta, everything. Here when it comes to v, it's the width of the vehicle or width between the wheels of the object. When it comes to g, this is in case of rails. This is the gauge. We call g as the gauge distance or the distance between the rails of the railway line. Okay. So the next part we have to know about the reactions. So we know that whenever there is a contact surface, there comes the reaction. And between the surface and the object, there will be frictional forces existing. So if the body tries to move in the right direction, your frictional force at the surface will be in the left direction. If the body tries to move in the left direction, your frictional force will be towards the right direction. So this basically you need to remember to understand these force conditions here. So to calculate these reactions RA and RB of a vehicle moving on a level circular pulse. So this is not super elevated, so it's a level road. You just need to find out the reactions RA and RB. So consider a vehicle that is moving on the level circular path with O as the center shown in the figure. So if you're seeing this figure, we are taking a curve towards left, keeping this O as the center of the curvature. So the vehicle will be in equilibrium under all these forces. Let's see one by one. Before that, let's know the terms here in the figure. I said there are two contact surfaces due to the two wheels of the object, I can say. So they will be RA and RB. The distance between them, instead of taking B, they have taken 2B for an easier problem solving here. And there is this height h, that is the height of this centroid from the ground level, that is h. And R is the radius of curvature. And you're taking a curve towards left, so there will be a centrifugal force acting outwards, that is WV square by GR. So since your object tends to move outwards, the frictional force at these two surfaces will be acting inwards. At this condition, I can call it as FA, this condition as FB. And not to forget, weight of the object will be acting always vertically downwards towards the ground. So this vehicle will be under equilibrium under 4 conditions. So the first one is the weight of the vehicle, W, which is acting vertically downwards, and these frictional forces, what you see here, FA and FB, the reactions RA and RB, which is acting vertically upwards, and the centrifugal force, WV square by GR, which is acting radially outwards. So to keep this system in equilibrium, we know the conditions of equilibrium, 3 conditions of equilibrium. They are sigma h is equal to 0, sigma v is equal to 0, and sigma m is equal to 0. So we are going to make use of these things to find out the reactions here. So sigma h is equal to 0 gives us, we are taking right side positive and left side negative. Therefore, this will be WV square by GR minus FA minus FB is equal to 0. Next, sigma V is equal to 0. For that, we need to check for the vertical forces. Plus RA plus RB minus W will be equal to 0. I can rewrite this as RA plus RB is equal to W. And the third condition of equilibrium is sigma m is equal to 0. We are taking the point about A, sigma ma is equal to 0. So taking the moment about A, here FA, RA and FB are all passing through the point A. Therefore, the moment of all these 3 forces will be 0. So we are left with RB, W and the centrifugal force. The perpendicular distance between A and B is 2B, and the perpendicular distance between A and G is H. And the perpendicular distance between W and A, I mean, where the weight is acting, and A. This weight will act, since we are taking it as symmetric object, this distance will be B. So if we are taking the moment, we are taking anti-clockwise to be positive and clockwise to be negative. It is on the assumption we consider. Here, since RB is making an anti-clockwise moment about A, plus RB into perpendicular distances 2B, and this one is clockwise, so we are taking minus W into perpendicular distances B, and again this one is also making clockwise about A, therefore WV square minus WV square by GR into perpendicular distances H is equal to 0. If we are solving it further for RB, we will arrive at RB is equal to W by 2 into 1 plus V square H by B into G into R. So from these two equations, that is equation number 2 and equation number 3, if we solve further, if we substitute RB in this equation, we can get RA is equal to W minus RB. If we solve further, we'll end up getting RA is equal to W by 2 into 1 minus V square H by BGR. So therefore, we found out RA and RB reactions at both the wheels. RA, I can say, since the curve is towards the left, I can call this as the inner wheel and this as the outer wheel or outer edge. So the term remains to be the same, only the difference between these two will be this plus or minus. So in inwards, towards the inner edge, it's always minus. Towards the outer edge, the reaction will contain this plus term. You can remember, it will be easier to remember like that. Okay. Next one is expression for superelevation E. So remember that superelevation is denoted, we are considering it as E. We represent it with E. Theta is the angle of superelevation. Whatever the height you see, it is the height of superelevation, that is E, we call it as. So now superelevation is provided, so the object is tilted a little. All these conditions remains to be the same, but with some projected angles. Weight will always act vertically downwards, and here they have taken B to be the width of the road. So for this condition, W is the weight of the vehicle, R is the radius of curvature, and V is the velocity, B is the width of the pavement, or in general we can take it as between the rails, distance between the rails when it comes to the railway system. And theta is the angle of super elevation that is being provided, and E is the super elevation, that is this height, and R is the reaction acting perpendicular to the surface. We have generalized more here, so we have taken B as the width of the road itself, and instead of taking two surfaces, we are considering altogether effectively as uh, one contact surface, or these two reactions put together. We are taking, instead of RA and RB, we are taking one reaction R, which is always acting perpendicular to this surface. Reaction, remember that it will always act perpendicular to the surface. And we also have this radially outwards acting centrifugal force. F is equal to WV square by GR. And all these, since the surface is elevated for an angle of theta, all these will have an angle of theta. So weight will have an angle of theta with this reaction, and this reaction will have angle theta with the vertical, and here the centrifugal force will be inclined with an angle of theta with respect to the horizontal of the object. So moving further, even here, to keep this condition in equilibrium, we make use of the conditions of equilibrium. Sigma h is equal to 0. If you make use of it, what happens is, this is the horizontal direction, this is the vertical direction, right? So this is acting in positive direction, that is plus WV squared by GR. Then this is vertically downwards, so we can't take this, but this reaction is inclined with respect to the vertical. So if we resolve, it will be in the negative side. So minus R sine theta is equal to 0. No other forces. Only this and the horizontal component of reaction, that is R sine theta. You know that the nearer side will be cos and the farther side will be sine. I can rewrite this as R sine theta is equal to WV square by GR. So this is the first equation. Next condition is sigma V is equal to 0. Summation of all the vertical forces is 0. W is acting vertically downwards, so I take it as minus W. And the vertical component of the reaction will be acting upwards. So plus R cos theta is equal to 0. So therefore I can rewrite this as R cos theta is equal to W. So using these two equations, 1 and 2, by dividing them, I can get dividing 1 by 2, r sine theta by r cos theta. That is, r gets cancelled, tan theta is equal to, if I solve this, I'll get it as v square by gr. That is, tan of this angle of super elevation will be equal to v square by gr. To simplify further, I'll take this triangle OMN, what we see in the surface. Okay, so since compared to the road's width, this theta will be very small, we can take OM is almost equal to OM. Since theta is very negligible, we can take OM will be almost equal to OM. So if OM is B, the distance of OM is B, so ON also will be equal to B. Correct? So in this triangle, if I take tan theta is equal to opposite by adjacent, that is Mn by On. Mn we have written here, this is nothing but the super elevation E divided by B. Since we have taken theta is very small, On also will be equal to B. So tan theta is equal to E by B. So using these two equations, we can write E by B is equal to V square by GR. We want the expression for super elevation, that is E. So I can write E is equal to V square into B divided by GR. So this, when it comes, when the term comes B, it is for the roads. So when it comes to railways, instead of B, replace this B with G. That is the gauge of the rails. So for rails, it will be E is equal to V square G by GR. So this is the expression for super elevation. So the formulas we learned until that we have to remember for the problems that are coming further. They are, let's just pressure. For skidding on level road, we have the condition V is equal to mu into GR. And for overturning on level road, we have V is equal to root of GRB by 2H. Conditions for skidding on banked road, this one. Condition for overturning on banked road for roads, and these are for railways. And finally, the super elevation expression for roads, E is equal to V square V by GR. If it is for railways, it will be V square G by GR. And also remember that tan theta gave us E by B. So in the theory part of the super elevation, these might be this important question. You can make note of it. And these are the references. Thank you.